Hello everybody and welcome to another episode of Math with Mr. Emond. Today we are starting a new unit on systems of equations. And we're going to be starting off by just looking at solving systems of equations graphically today. And so let's get started. In Math 10 we looked at linear equations, systems of linear equations in particular, where we might have one line intersecting with another line. And what we found is that the solution for the system of linear inequalities would be the point where the two intersect. So this point here, which in this case would be 1, 2, 3, and 1, 2, 3, 4. So we would write that as 3, 4. And that would be our solution for this system of linear equations. This year, what we're going to do is we're going to extend that idea a little bit more. And we're going to be including systems of linear-quadratic and quadratic-quadratic equations. So we have examples of them up here as well. And remember, the solution to any system of equations is going to be an ordered pair, like we did in that first example, that satisfies both equations in a system, no matter what that system is. And so we can see here, this is a linear-quadratic because there's a line and a quadratic equation here. And we can see there's 2 points of intersection, one there and one there. And so our solution to this one would be -1, 2, 3, 4, 5, 6, 7. So this would be -7 on the x and 1, 2, 3, 4, 5, 6 on the y. And it has another solution here, which is 1, 2, 3, 4, 5, 6 on the x and 0 on the y. So two solutions, 2 points of intersections. And then of course on this one, there's an intersection here and an intersection there. And those are going to be our solutions. So this one has the point -1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4. And this one has the solution 1, 2, 3, 4. So -4 and 1, 2, 3, 4. -4 and -4. And that's basically how we're going to be solving these, is graphing them and then looking at points of intersections, because those points belong on both functions. All right, let's get started. Let's look at the different cases. So when we're dealing with linear quadratics, there's going to be some cases. Maybe there's going to be no point of intersection, and that just means that there's no solution, like in this example here where they don't intersect. There might be one point of intersection, which means you might have just one solution at that point. Or there might be 2 points of intersection, which means you're going to have 2 solutions there. Let's look at your cases for quadratic quadratics. You could have no point of intersection, where your 2 quadratics don't meet at all, and that would be no solution. You could have 1 point of intersection and 1 solution, or 2 points of intersection, so 2 solutions there. All right. We should remember that any ordered pair that satisfies both equations in a system of linear quadratic or quadratic quadratic equations is a solution of that system. So for example, if we find graphically that 2, 4 is a solution of the system, then when we plug them into our equations, they should satisfy both equations. So let's go ahead and try that out. For our first equation, we have f of x equals x plus 2. Remember, that's basically just saying y equals x plus 2. And let's plug in our value. So y was found to be 4, and x was found to be 2. Does 2 plus 2 equal 4? Of course it does. Let's try the other one. We have y equals x squared. Again, our y value is 4. Our x value is 2. Is 2 squared 4? Yes, it is. So that works as well. This is going to be how you verify your solutions once you find them. You use those points, you plug them back into your original equations, and you make sure that they actually are solutions of both equations. All right, let's try this first example here. So we have Blythe Hartley, who's from Edmonton, Alberta, and she's one of Canada's best springboard divers. She's doing training dives at the moment from a 3-meter springboard, and her coach uses video analysis to plot her height above the water. Which system could represent this scenario? Explain your choice and why the other graphs do not model this situation. All right, let's look at our graphs here. So here it seems like she's starting off at a height. She's in blue, the green is the diving board. So both her and the diving board are at 3 meters, but this is obviously, the diving board's not going to be falling into the water here as it does in this diagram. So this doesn't work. Here we have the diving board remaining at the same height. So if that is 3 meters above the water, then why does it look like she's jumping from 6 feet above? Is she floating above the diving board? That doesn't make sense. Let's look at this one. So we have a stationary diving board, which is good. But again, she's starting way above the diving board. You can't be jumping out of midair. She has to be standing on the diving board. So it must be this one here, where you have a stationary height for your diving board, which is not going to be moving. You start at that height and jump above it, and then you fall back in the water. So the answer has to be system D, and we just interpreted the points of the intersection for the system we chose. So that's it for this example. Why don't you go ahead and give this one a shot? So you have 2 divers starting their dives at the same time. One diver's jumping from a 1-meter springboard and the other's jumping from a 3-meter springboard. Their heights above the water are plotted over time, and so we have the graphs here. Which system could represent the scenario? System A, B, C, or D? Go ahead and pause the video and come back when you think you have it. Welcome back. Hopefully you chose system A. This is the only one that works. Why? One diver starting from 1 meter, one diver starting from 3 meters, and of course they jump off their diving boards and they're not going to hit the water at the same time, and that's okay, that's what's expected. Why does this one not work? Well, it's showing diver 1 starts at 0, which is not true. Diver 1's jumping from 1 meter springboard. Here both start from 0, and here both are starting from 0 and late. So system A is the only one that works. Explain why there is no point of intersection in the system you chose. So why in system A is there no point of intersection? I'll let you think about that for a second. The answer is, if one diver is jumping at a greater height, then they're going to be in the air for longer periods of time, and therefore diver A will hit the water and diver B will hit the water about a second or so later. That's why. Let's try out example 2 here. So what we're doing is we're going to be solving the following system of equations graphically. And so let's get started on that. We're going to have a couple strategies we can use here. The first one is, let's isolate our y. I mean, that's what we're used to doing, right? So I'm going to add y to both sides to isolate my y, and that's going to give me y equals 4x plus 3. Now I can graph this. This is in slope-intercept form. This is a line where the slope is 4 and the y-intercept is 3. That's really all the information I need. So here's my y-intercept, and my slope is 4, meaning it's a rise over run of 4. So rise of 4, run of 1. And rise of 4, run of 1 in the opposite direction because I'm going in negative there. And that's enough for me to plot my lines. So I'm just going to switch to a line here, change my color to blue, and get some arrowheads. And we should be able to plot a nice line there. There we go, going through our points. So there is our first equation. Let's go ahead and work on the second one now. So we'll do this in red. And let's isolate y again. So we're just going to add y to both sides. And that's going to give us y equals 2x squared plus 8x plus 3. And now this, we can plot some points from this immediately. But what I might do is put it into vertex form. And the way I'm going to do that is by, there's two methods I could actually use here, and maybe I'll do it with both methods. Let's complete the square first. So we're going to isolate our first two. So, and I'm also going to factor out the 2. So this is going to be x squared plus 4x plus 3. So all I did is I isolated my first two terms, the x squared and the x, and I factored out the 2 in the same one. Now I'm going to divide my b value by 2. So 4 divided by 2 is 2, and I'm going to square that. 2 squared is 4. So inside my parentheses, I'm going to add 4. And now outside, I'm going to subtract 4. But I have to remember that there was a 2 here. So that 2 is going to multiply by my -4. And so instead of -4, it's -8. And then, of course, there was the plus 3 there. If you need a refresher on completing the square, make sure you go back and watch the videos on that. So now I have y equals 2. This is a perfect square. So this is x plus 2 squared. And -8 plus 3 is -5. So there we go. I used completing the square in order to convert from standard form into vertex form. Vertex form is going to be a little bit easier for me to graph. And so now I can go, my vertex is -2, -5. 1, 2, 3, 4, 5. Look at that. There's a point of intersection. Now my a value is 2. So I'm going to use my knowledge on how normal parabolas work. And normally I would go up 1 or over 1, up 1. But now because it's 2, I need to multiply that by 2. So instead of over 1, up 1, I'm going to go over 1, up 2. And of course, mirror it on my axis of symmetry. Normally it's over 2, up 4. Now we're going to go up 8 because our a value is 2. And I just determined another point of intersection. And this, I could go, and normally it's 3 and 9, but now it's going to be 18, but that's going to be like up here. So I think this is enough for me to graph my points. Doesn't need to be beautiful because we're sketching. And the real point of this was to determine my points of intersection, and I was able to do that because they just worked out really nicely here. So what is this? This is -2 on my x and 1, 2, 3, 4, -5 on my y. And this point of intersection is, of course, 0 and 3. And so there's our solutions. And we need to verify them now. So our first solution was 0 and 3, and our second solution was -2 and -5. And now we need to verify them by plugging them back in to both equations. So there's actually going to be 4 steps that you do here. So let's start with this one. So we're going to have 4 times x, which is 0, minus y, which is 3, plus 3 equals 0. Let's see if that works. 4 times 0 is 0, minus 3 plus 3, of course, is 0. That does work. Let's plug it into our second equation. 2 times 0 squared plus 8 times 0 minus 3 plus 3 equals 0. Let's try that out. This is going to be 0 plus 0 minus 3 plus 3 equals 0. Yes, that works. All right, let's try this other point. Make sure it's a solution of both. So we have 4 times -2 minus -5 plus 3 equals 0. Here we have -8 plus 5 plus 3 equals 0. -8 plus 8 is 0. Yes, that works. And finally, 2 times -2 squared plus 8 times -2 minus -5 plus 3 equals 0. Let's check it out. -2 squared is 4. 4 times 2 is 8. minus 16 plus 5 plus 3 equals 0. 8 minus 16 is negative 8. Negative 8 plus 8 is 0. Excellent. We have just verified our solution. That was through completing the square. Before we make it your turn, I'm just going to remind you of one more strategy that you can use rather than completing the square, is remember that your vertex is PQ. And there is a formula you can use to find P. P is negative B over 2A. Now that in our case would be whichever formula you're doing it for. So let's do it for this one, of course. Our B value is 8. So that would be negative 8 over 2 times our A value, which is 2. This gives us negative 8 over 4, which is negative 2. And of course, we can see here the P value of our vertex was negative 2. Now, how do you find the Q value? Well, you plug in whatever value you found for P. So there's our equation. 2 times negative 2 squared plus 8 times negative 2 plus 3 is going to give you your Q value. So you just take your equation that you didn't change and you plug in the value that you found for P. And you're going to find Q to be equal to negative 5 here. And now you have your P value and your Q value. Your P value is negative 2. Your Q value is negative 5. And your A value is always the same. In this case, it's 2, right? Because it was 2 over here. And we can then use these three pieces to make our vertex form equation, which of course would be y equals A times x minus P, which would be x plus 2 squared plus Q, which would be minus 5. And of course, you can see that this and this are exactly the same. Two very different methods that will get you to the same place. So now use either strategy, completing the square or determining PQ algebraically and then constructing your vertex form from that to solve this problem. It's going to be your turn. Solve the following systems of equations. Of course, do it graphically and then verify your solution. We'll see you when you return. Welcome back. Let's go through the solution. So for this one, I demonstrated the PQ way of doing it. So first, isolate your equation, and then I'm going to find my P by doing negative B over 2A. What is my B value? Well, that's 2. So negative 2 over 2 times A, which is negative 3. So my P value is 1/3. Now what do I do to find my Q? Well, you plug in whatever value of P that you had. And so we do negative 3 times 1/3 squared plus 2 times 1/3 plus 4. I'm just substituting in 1/3 for my x values. And when you solve, you're going to find Q equals 13 over 3 or 4 1/3. And of course, your A value is exactly the same. And so we can go ahead and write a vertex form equation now. You could make it y equals negative 3 x minus P squared plus Q. Okay, so now we have our equation in vertex form. And you can go ahead and try graphing this. So we know that our vertex is at the point 1/3 and 4/3, which is right there. So there's our vertex. And you can see I have other points kind of plotted in here. How did I get those? Well, what I did is I used my equation, this equation here. I used this equation and I plugged in different x values to find corresponding y values. And so let's go ahead and see how I did that. So what happens when you plug in an x value of 0? Well, you can see here this becomes 0 plus 0 plus 4. You have a y value of 4. So when x is 0, y is 4, and that's that point here. And of course, I can mirror that on my axis of symmetry. When I plug in an x value of 1, I get a y value of 3. So x value of 1, y value of 3 right there, and mirror it on my axis of symmetry. Plug in an x value of 2, get a y value of -4, which is right there, and mirror it on my axis of symmetry. Plug in an x value of -1, get a y value of -1, and mirror it on my axis of symmetry. So now I would be able to plot through those points and make a nice parabola here to express my quadratic equation. All right, now you have to do your other equation. And so first isolate your y, and now that should be enough information. It's a negative slope with a y-intercept of -2. So there's your y-intercept of -2 with a slope of -1, and you can basically just, plot a couple more points. There's 4 points that I plotted, and then draw your line through those points, and you should be good to go from that point. And so where are our areas of intersection? They should be quite easy to spot, right there and right there. That's where the two intercept. And what are those points? Well, our first point there is 2 and -4, and our second point here is -1 and -1. And so of course, that's what you're going to use to verify your solutions, because those should be the solutions. And so you have to test them. So input an x value of -1 and a y value of -1 and test it, and it works for both. Plug in your y value of -4 and your x values of 2, and it should work, and it certainly does. So there you go. That's it for solving linear quadratic equations. In the next video, we're going to be solving systems of quadratic-quadratic equations. Looking forward to it. You should be too. See you soon. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.